Hello everyone, my name is Ellie Goldberg and I'm excited to be joining all of you across the globe from the smallest state in the United States, Rhode Island. I'm looking forward to becoming a familiar and hopefully friendly face as I bring to you some of the Math Fix tasks and videos this year. Today's Math Fix is brought to you by F.BF.1.A, which asks students to determine an explicit expression, a recursive process, or steps for calculation from a context. Let's take a look at our problem today. Students are asked to find a range of numbers that produce a desired result by playing the double add 5 game. Where might students start with this? There are a range of approaches. Some students might start by simply guessing a number and checking to see what they get. For example, if I start with 10 and go through the recursive process of doubling and adding 5 3 times, I end up with 115. From there, students might conclude that there could be a smaller number that gets closer to 100 and try 8 or 9. They may notice the pattern that for each successive number we start with, the end result increases by 8. Another approach to the initial problem could be to work backwards and reverse the process. For example, if I start with 100 and subtract 5, then divide by 2, I get 47.5. Some students may stop there and realize that since the problem asks them to start with a whole number, this value cannot make sense. They may choose to guess other numbers, like 101, and so on, until they get a number that achieves a whole number result, like 107. Other students may continue the process 3 times even after getting a result of 47.5 to get a result of 8.125. Students can reason then that since they need a whole number to begin with, 9 would be the smallest whole number to get you to 100 or greater playing the double add 5 game. The problem gets interesting when we extend it to ask students to achieve an end result of 1,000 or greater. Here students may still want to continue using an approach they already used for 100, but they might realize that they can create an explicit expression to generalize their recursive process as the standard discusses. Having an explicit formula allows them to generalize and solve for any other result you may give them. One interesting extension might be to put a context to this problem or ask students to create one themselves. And there you have it, folks. There are many other ways to approach this problem, and we'd love to hear about those ways. If you've done this problem or plan on doing it soon, please share with us what you've done with this month's Math Fix. Until next time.